We're finding reference angles, or using reference angles to find trigonometric functions. And I went ahead and brought the unit circle over here because there's some things we need to start working on. And specifically what we're actually looking at is trig functions with reference angles that correspond to special angles, which equate to 30, 45, and 60 degrees, or pi over 6, pi over 4, pi over 3 as our reference angles. But I want to bring in a couple of patterns that we see existing here and see if we can't begin to start, because we really kind of need to start memorizing these values at these specific points of these special angles. Now, here's one pattern. If I look at anything that's going to have a reference angle of 30 degrees, I see that it's related to and equivalent to pi over 6. And here at 150 degrees, which would have a reference angle of 30 to the nearest x-axis, I see 5 pi over 6, or in other words, it's something pi over 6. What about down here at 210? 210 would also have a reference angle of 30 degrees. 210 minus 180, 30 degrees. I see again that pattern of 7 pi over 6, something pi over 6. And again at 330. Well, here at 330, which would have a reference angle of 30 degrees, I see 11 pi over 6, something pi over 6. And so anytime I see something pi over 6, I know that the reference angle must be 30 degrees, or just pi over 6. Now I see another pattern emerging right here. At 45 degrees, I see pi over 4. My reference angle there would be pi over 4. What about at 135 degrees? Which also would have a reference angle of 45 degrees. Well, there's 3 pi over 4. In other words, I see that over 4, something pi over 4. Again at 225. 5 pi over 4, something pi over 4. And look what else. If there's a 5 out there, I'm thinking, ooh, is this a special angle? Does this relate to a 45 degree or pi over 4 radian angle? And again at 315. I see that 5 as that last unit. I'm thinking, okay, woo, must be something pi over 4. I bet it is. And in fact, it is 7 pi over 4. And then I see a third pattern here at 60 degrees. Well, at 60 degrees, that's pi over 3. That would be my reference angle. Well, what about up here at 120 degrees? I see 2 pi over 3. So I see something pi over 3. I'm thinking reference angle 60 degrees. See, reference angle 60 degrees. I see it again down here at 240. 4 pi over 3. Reference angle 60 degrees. And what about at 300? 5 pi over 3. Something pi over 3. Reference angle 30 degrees. Now, another pattern. And let's think about all students take calculus. Now, at pi over 4, notice that my x-coordinate, or my cosine, is square root of 3 over 2, and my sine is also square root of 2. My y-coordinate is also square root of 2 over 2. And I see again this pattern emerge over here at 3 pi over 4. Well, I'm seeing the basics of square root of 2 over 2, but the cosine, or the x-coordinate, is negative. All students. My sine function is positive. In the first quadrant, they're both positive. In the second quadrant, the sine is positive. What about in the third quadrant? Well, my tangent functions would be positive, but everything else is negative. And again, there's negative square root of 2 and negative square root of 2. Beginning to make sense. Pattern here in the fourth quadrant. Well, my cosine is going to be positive, my x-coordinate, but my y-coordinate is going to be negative. And I see that square root of 2 over 2, comma negative square root of 2 over 2. Now I see this pattern exist for pi over 6 or 30. I got square root of 3 over 2 and 1/2. And then as I move to the second quadrant, where I'm expecting the sine or the y-coordinate to be positive, well, I see that it's positive, and the cosine is negative, has become negative. They're both negative down here at the third quadrant. Negative square root of 3 over 2, 1/2. And on to the fourth quadrant, where we see that the cosine or the x-coordinate is positive, but the sign is negative. Square root of 3 over 2, negative 1/2. Another pattern emerging right here. Look at pi over 6. Compare it to, pi over 3, and compare it to pi over 6. Well, I see similar values. They're just reversed. Now the x-coordinate or the cosine is 1/2 and the sine is square root of 3 over 2. And if I look, I see that pattern of all students take calculus emerging all the way around anytime my reference angle might be pi over 3 or 60 degrees. Now, we're asked to find the tangent of 5 pi over 3. So if I see 5 pi over 3, well, my reference angle is going to be what? It's going to be pi over 3. Now, what quadrant am I going to be in? This is positive, right? Well, it's not pi over 3, which would put it in the first quadrant, so I must be down here in the, I got to find 5 pi over 3. Well, it's right here. 5 pi over 3 is down here in the fourth quadrant, right? There it is. Well, since it's pi, and my reference angle is pi over 3, so I'm thinking right up here. Now, what is the tangent expressed in terms of sine and cosine? Well, the tangent is equal to the sine, value of the sine, over the cosine. Well, there in the fourth quadrant, with a reference angle of pi over 3, what would be my sine function? Well, it's negative square root of 3 over 2. And what's my cosine? It's in the fourth quadrant. It's positive 1/2. Now, let's go ahead and find the tangent then of sine over cosine with a reference angle of pi over 3 in the fourth quadrant, where my sine function is going to be negative and my cosine is going to be positive. So we got the tangent of 5 pi over 3, which has a reference angle of pi over 3, and that's equal to negative square root of 3 over 2 over 1/2. Well, to go ahead and solve that, I take negative square root of 3 over 2, and I multiply it by the reciprocal of the cosine, which is 2 over 1. And look, my 2's cancel. And so at 5 pi over 3, my tangent with a reference angle of pi over 3 is going to be just negative square root of 3. Now, I may have probably complicated that by bringing in the unit circle, but try to get that in your head and focus on these values right there. If you can focus on these and then learn that all students take calculus, you can determine whether they're positive and negative depending on what quadrant they're in. Okay, well, this time we're looking for the sine of 5 pi over 6. Well, what's my reference angle going to be? My reference angle is going to be pi over 6. Now, 5 pi over 6 is less than pi, so this is going to be into the second quadrant, right? All right, well, what's pi over 6? That's the reference angle. What's the sine value at pi over 6? Well, it's the y-coordinate. And so my reference angle here then tells me that sine must be 1/2. Now, which quadrant am I in? I'm at 5 pi over 6. And what do we say? All students take calculus. So in the second quadrant, my sine function is going to be positive. So at 5 pi over 6, which has a reference angle, 5 pi over 6, which has a reference angle of pi over 6, it's in the second quadrant. My sine function is going to be positive. Well, it's just simply 1/2. All right, one more. Okay, now let's complicate this a little bit more. It's the secant of negative 135. Okay, I see that 5. 135, that last unit of 5. I'm thinking, this must be something pi over 4. Must be. Bet it is. Well, let's see. But we're going in a negative direction, so I'll go here, negative 90. Which quadrant is this going to put me in? This is going to put me in the second. Oh, it's going to put me in the third quadrant. Here's 90. Here's another 45 degrees, so I'm right here at 225 or 5 pi over 4. Well, what's my reference angle? My reference angle is just simply pi over 4. Well, square root of 2 over 2, square root of 2 over 2. I'm in the third quadrant. What we say? All students take calculus. Now, the secant is the inverse of the cosine. And if I'm in the third quadrant, both the cosine and the sine are going to be negative. That's the only way the tangent there could be positive and be the only one. Everything else is negative. So this secant then is, let's say the secant, and I'm not going to write the negative 135, is equal to 1 over the cosine. Well, what's the cosine of pi over 4 reference angle in the third quadrant? Well, the secant then is going to be equal to 1 over the square root of 2 over 2. And then to finish that, let's take this right over here. If I'm going to solve that, then the secant at negative 135, we could say then is equal to, I'm going to use the reciprocal to multiply that by 1. Well, I got 2 over the square root of 2. And is it positive or is it negative? Well, it's negative, right? 1 over the cosine. I should put a negative down here. Well, I got to rationalize this denominator. So let's do that by multiplying by the square root of 2 over 2, the square root of 2 over the square root of 2, and that's going to equal 2 times, I should say negative, I forget my negative, negative square root of 2 over 4, that's 2, wait, I'm making a mistake here. This is equal to negative 2 square root of 2 over 2. Well, my 2's are going to cancel. That's going to become negative 1. And so the secant at negative 135 in the fourth quadrant with a reference angle of pi over 4 is going to be negative square root of 2. Shazam. Hope that wasn't too jumbled up. Maybe make some sense of it. We'll have to work on it in class, you know.